So in this problem, we are being provided with two non-zero finite sets A and B. And we also have a relation R, which is defined as less than going from A to B. Then our goal will be to write down the set of ordered pairs that corresponds to the relation R. We also need to find out the inverse of the same relation R and determine the domain and range of each of the relation R as well as its inverse. Okay, so let us begin. So here we have the two sets A and B. So let's write down the two sets. We have the set A given by the set containing the elements 1, 2, 3, 4, and 5. And next we have the set B, which contains the elements 1, 4, and 5. Okay, fine. Now we have a relation which is a relation defined from A to B and is defined as less than. Now what does it mean when it says less than? So we'll have to understand the relation R. So a relation R, let's say it is a relation that is a set. R is a relation which is a set which contains the set of ordered pairs x comma y. And the relation between the relationship between x and y is such that x is less than y. And what are x and y? X clearly belongs to the first set A and y is going to belong to the second set B. So this is our relation R that we need to define. Okay, let's begin. So we have the relation going from A to B, which means that R is going to be a set containing ordered pairs. So let's say if we consider the first element x to be equals to 1, then can we pick up any element from the set B such that the x is always less than that element in y? So we cannot pick up y to be equals to 1 from the set B because 1 is not less than 1. However, we can pick 4 and 5. So clearly we can consider y to be equals to 4. If we consider x to be 1, then we can also consider y to be equals to 5. That means clearly there is a relationship between x and y, so where we can say 1R4, this is a relationship. So x equals to 1, y equals to 5. We can say that 1R5 clearly is a relationship as 1 is less than both 4 and 5. So using 1R4 and 1R5, we can define two ordered pairs. One will be 1 comma 4 and the other will be 1 comma 5. Okay, next what we'll do, we'll pick up the element 2 from set A. So if we pick up 2 from set A, we have to pick up elements from set B such that that element is greater than 2. So we cannot pick up 1. So here we can pick up 4. So 2R4 is going to be a relation. We can also have 2R5 because 5 and 4 are both greater than 2. So 2R4 is going to correspond to the ordered pair 2 comma 4. 2R5 is going to correspond to the ordered pair 2 comma 5. Okay, fine. Next we will choose 3. So if we choose 3, then 3R4 and 3R5 are going to be two relation. So we have 3 comma 4 and then we have 3 comma 5. Next, if we consider x to be equals to 4, we cannot consider 1 and 4 from the set B because 4 is not less than 1 and also 4 is not less than 4. However, we can pick up 5, which means there's a relation between 4 and 5. So 4R5 is going to be a valid relation. So our ordered pair is going to be 4 comma 5. And finally, if we pick up 5 from the set A, now 5 is not less than any of the element in the set B, so we will not find any valid relation. So our relation R consists of the following ordered pairs 1 comma 4, 1 comma 5, 2 comma 4, 2 comma 5, 3 comma 4, 3 comma 5, and 4 comma 5. Okay, so now that we have defined the relation R, let's find out its domain. So domain of the relation R, this is simply going to be the first element of each of the ordered pairs. So we have 1, 1, 2, 2. We don't have to consider the repeated values, so we only consider 1 and 2. Next we have 3 and then we have 4. So 1, 2, 3, 4, these are going to be the domain of the relation R. What about the range? What is going to be the range of the relation R? So this is simply going to be a set. The set is going to contain elements which are going to be picked up from the second element of each of the ordered pairs. So here we have 4, 5, 4, 5, 4, 5, 4, 5. So that means 4 and 5 are the two elements that are going to be the range of the relation R. Okay, so now that we have R, we can immediately define its inverse. All we have to do is consider the ordered pairs in each of the relation, the ordered pair in the relation R, and what we'll do, we're going to interchange the position of the ordered pair. That means 1 comma 4 is going to give us a new ordered pair 4 comma 1. 1 comma 5, that's going to give us 5 comma 1. So 2 comma 4 becomes 4 comma 2. 2 comma 5 becomes 5 comma 2. 3 comma 4 becomes 4 comma 3. 3 comma 5 becomes 5 comma 3, and then 4 comma 5, that gives us 5 comma 4. So this is going to be the inverse of the relation R, and that we have the inverse of the relation, we can define the domain. So domain of R inverse, that is simply going to be equals to the range of R, which is given by the set containing two elements 4 and 5. We can verify that. All you have to do is pick up the first element of each of the ordered pairs. So that's going to be 4 and 5, and then we have the range of the inverse R. The inverse relation R is simply going to be equals to the domain of R. So that's going to be 1, 2, 3, and 4. All you have to do is pick up the second element in each of the ordered pairs of R inverse. Fine.